In today's class, we'll be looking at stoichiometry, one of the most important aspects of chemistry. This aspect deals with calculation. Okay, so and if you're writing JAMB or NECO or irrespective of the exam you may be writing, this class is for you. Okay, all right. So okay, all right, so let's continue. Let's continue. All right, this formula, this structure you can see here, you have to take note of this if you want to be good at calculations theory. If you want to be good at calculations generally, you have to take note of this. Take note of this formula, that 1 mole of any substance. Before, let me introduce to you what stoichiometry is all about. As I've said, stoichiometry is a calculation aspect of chemistry. It comes from two words. The first one is stoichion. And the second one, this stoichion means atoms, and the second one is metron. This metron means measurements. That is where the word stoichiometry comes about. It comes from these two words, stoichion, which means atoms, and metron, which means measurements. So you have to take note of this formula, that 1 mole of any substance. I just want to go straight to the main points. I don't want to waste time here. I don't want to waste time in the introduction part. So 1 mole of any substance is given to be equal to 22.4 dm cube at STP. This is a volume. 1 mole of any substance is equal to what? Molar mass. 1 mole of any substance is equal to what? Avogadro's number. I think you are familiar with Avogadro's number. You are familiar with that. So 1 mole of any substance is equal to what? 96,500 coulomb. That is 1 Faraday. You have heard about Faraday under electrolysis. Okay, 1 mole of any substance is equal to this, is equal to this, is equal to this, is equal to this. But our major concern this evening, I'm not touching these parts. I'm touching this, and this. Our major calculations will be within 1, 2, 3, 4, within these 4. Okay, because these are the most common parts where JAMB used to set. The most common part in the aspect of stoichiometry, where JAMB used to set a lot of questions. All right, please take note of that. All right, so let's look at a question. Let's look at this question. This question says, question number one says, calculate the number of moles present in each of the following. Believe me that every question you will see here is JAMB likely questions. I know what I'm telling you. Please take all these questions serious. Make sure that you stay. I'm not going to spend much time. Please make sure that you stay connected till the class end, please, because we are going to look at JAMB likely questions. Although we may not be able to finish stoichiometry today, but we touch some major parts. Maybe in our next class we try to finish the remaining parts. Okay, now let's say we're asked to calculate the following. Number one, now we're asked to calculate the numbers of moles in 5.3 grams of Na2CO3. What is this compound called? This compound Na2CO3, what is it called? If you know it, drop it in the comments. Na2CO3. Let me see your response. Please drop it in the comments. What is it called? Someone said hi. Okay, you're welcome. So what is this compound called? Drop it in the comments. This compound, Na2CO3. All right, what does Na here represent? It represents what? Sodium. C represents carbon, and O here represents what? Oxygen. Okay, now for question number 1 now, I'm going to show you different ways they can ask you to calculate moles, and I'm going to show you tips, easy way you can get them without you stressing yourself. Okay, now it says calculate the numbers of moles present in each of the following. Now for number 1 now, we are calculating the numbers of mole that is present in this compound. Numbers of mole that is present in this compound. First thing, whenever you are given calculations, even though if you don't know the formula, try to write the formula. I mean, try to write out the parameters given. There are times that it's during, okay, someone said, okay, sorry, I can, okay, someone said, is it that it's not clear? Okay, you're welcome, you're welcome, you're welcome. All right, you're welcome. So, this question now, we are given mass of this compound. We are given a mass of this compound, and we are asked to calculate the numbers of moles. We are asked to calculate the numbers of moles. Take note, as I've said, first thing you need to do is, should I write out all the questions out first? Okay, let me write out all the questions. For question number 2, let's write out the questions before we start solving. For question number 2, we have 4 points. You will see, from this video, you will see the importance of this diagram that is here. From this video, you will see the importance of this diagram. If you can understand this diagram, I bet you that if you will come across any calculation in moles, you'll be able to make attempts and solve it. I'm telling you, if you can master this diagram very well. Okay, we have 4.25 times 10 raised to power of 21 atoms of copper. I'm not going to write the options, please. I'm not going to write the option. I don't want to waste time, so I'm not going to write any option for that. The third question is 200 cm cube of 0.025 mole per dm cube. Mole per dm cube HCl solution. The third one is, the fourth one says 16 dm cube of hydrogen gas at STP. And the fifth one is 250 cm cube of an ID gas. Please let me know. Can you see this my handwriting? Can you see it clearly? Please let me know in the comments. Can you see it clearly? Let me know in the comments. Can you see this clearly? Okay. What about that? Please let me know. Can you see it clearly? Let me know. Let me know. Someone said yes. Please let me know if you can see it clearly in the comments. I need the response from you guys. Okay, let's continue. 250 centimeter cube of an ID gas exerting a pressure of 720 millimeter mercury at 37 degrees Celsius. All right, so first of all, we'll be solving these questions. I'm going to show you this. Now, what we're asked to calculate in all of them is T moles. So there are different ways. You can see different ways they ask you to calculate moles with different parameters given. With different parameters. Okay. Now, the first one says we're given, let's start by writing our solution. For the first questions, we're asked to calculate the numbers of mole. But what are those parameters that we're given? We're given the mass of the compound. So given that, you don't need to write all these givens in an exam. So you can just write your parameters 5.0, 5.3 gram as the what? As the mass. Now, you try to think, relate that, oh, which formula that relates mass, what you are given and what you are asked to calculate, which formula relates them together? Think. Have you heard about mole equals to mass over molar mass? Have you heard about that? Try to relate using your parameters that was given and what you are asked to solve, what you are asked to calculate. That is how you can easily remember formula in an exam hall. Now, remember the formula that says mole equals to mass over molar mass. Mass over molar mass. Now, the mass of this compound that we have to calculate its mole, the mass has been given already to be this. But we still need to calculate the molar mass of this compound. Please take note of something. The way you calculate number 1 is different from the way you calculate number 2. By the time you want to calculate number 2, we will apply this diagram. We'll make use of this diagram. By the time you want to calculate number 4, you will apply this diagram. Please take note of that. Take note of that. Okay? And even by the time you want to calculate number 3, you apply it. So please take note of that. All right. So take note that is how you can easily remember formula. Mole equals to mass over molar mass. Then after getting that, you know that your mass has been given to be this. What you need next is your molar mass. And how do you calculate your molar mass? You bring out the compound, which is this. You bring it out. You calculate the molar mass by saying N sorry for that. Sorry for that. I didn't know that the sound is off. Sorry for that. Okay, sorry for that. I'm so sorry. All right, let's continue. Okay. Let's continue. Now, you are given that. Please confirm you can still hear my voice. Please confirm. Can you hear my voice? Please confirm. Can you hear my voice? Let me know. Let me know. Please, I just need one response. Okay, okay. Thank you very much. Thank you very much. All right, let's continue. So now, since you already know that sodium is 2, so we multiply the mass number by 2. And carbon is 1, so you write it as 12. Okay? So oxygen now. How many oxygen? What's the molar mass of oxygen first? The molar mass of oxygen is 16. How do you know? How do you determine molar mass of a compound? For example, if I just throw you a compound that, oh, calcium. What is the molar mass of calcium? What's the molar mass? One of the way you can easily know is that although it's not applicable to all of them, take note, it's not applicable to all of them. If you want to find molar mass of a mass number of a compound and of an element,
mass number of an element, if you want to find the mass number of an element, one of the easiest way you can do it, especially element within the first 20 elements, like calcium. If you want to find the mass number of calcium, just multiply the atomic number by 2. There are some elements that after you multiply the atomic number by 2, you still need to add like 1 or 2. Okay, so the mass number of calcium now is what? The atomic number times 2, which is what? Which is 40. That is mass number. For example, let's look at another element, neon. Neon is in what number? Is number 10. You multiply its atomic number by what? By 2. That is how you get the mass number. So like that to some other elements, not all actually applicable to all of them. Like sulfur. Sulfur is the what number? 16. So multiply its atomic number by 2 to get the mass number. So that is how we get the mass number. So the mass number of oxygen, now oxygen is the number 8. So to get the mass number, you multiply oxygen by, we multiply the number, atomic number by 2. And when you multiply the atomic number by 2, which will be 16. So 16 now happens to be the mass number of what? Oxygen. Happens to be the mass number of oxygen. But how many oxygen that is now here? We have 3 oxygen. So you multiply that mass number by 3. So if you punch this in your calculator, 23 times 2 will be what? 46 plus 12 plus 16 times 3. That is what? That is 48. If you add them together, all of them will give you 106 gram per mole. Now, what you need here is that you have already been given the mass in the question, and you have calculated the molar mass to be this. So what you only need is to substitute your parameters into the formula and get the what? And get the mole. Okay, so let's do that here. So mole equals to the mass, which is 5.3, over the molar mass, which is 106. Okay, now if you punch that in your calculator, that will be 5.3 divided by 106. What does that give us? It gives us 0.05. You can see that. 0.05. So it gives us 0.05 what? Mole. That is one of the way you can come across mole question from mole in your exam. Another way you can come across question from mole is through this number 2. Look at this number 2 now. You will see that the way this number 2 question is being asked is quite different from the way question number 1 was being asked. Now question number 2 now, you are given in terms of what? In terms of Avogadro's number. Now you make use of the relationship between this and this to solve this number 2. The relationship between this and this. For number 4 now, we will make use of relationship between this and this. For number 2, relationship between this and this. For number 4, relationship between this and this. So please, this diagram is very important for you. Take note of that. Okay. All right. Let's proceed. So to solve number 2 now, we're given the numbers of atoms. We have to calculate. We are given the numbers of atoms to be what? We're given the numbers of atoms to be the atoms of copper to be this. But you need to write out this one first, that 1 mole of any substance is equal to the Avogadro number. That is for number 2 now. 1 mole of any substance. 1 mole of any substance. Now, the substance we are dealing with here now is what? Is copper. So I will say 1 mole of copper equals to, because 1 mole of any substance is equals to this. So 1 mole of copper will be equals to this. What is Avogadro number? Avogadro number is given to be what? What is Avogadro number? Avogadro number is 6.02 times 10 raised to the power of what? Times 10 raised to the power of 23. That is Avogadro number. That is Avogadro number. Yeah, that is Avogadro number. Okay. Now, 1 mole of copper, 1 mole of any substance is equals to the Avogadro number. So let's take the substance now to be copper. So 1 mole of copper is equals to the Avogadro number. That is 1 mole of copper is equals to the Avogadro number. Now you are now given this number of atoms, that if 1 mole of copper give you this one, how many mole of copper will it give you? So since this with numbers of atoms, I'm not going to write it here because this one deals with 1 mole, while this one deals with what? Atoms or numbers. So I will then write it that 4.25 times 10 raised to the power of 21 atoms. How many mole will it give us? If this 1 mole of copper give us this, or this one give us this, at least this Avogadro number give us this, how many mole will this one give us? So let's take it to be X here. Assume that we don't know it. Okay, take it to be X. So what you will do at this point is to do what? Let's assume you cross multiply. You cross multiply. So X times this is to give you what? 6.02 times 10 raised to the power of 23 X equal to, now this 1 times what is there, we still give you this. That will be 4.25 times 10 raised to the power of 21 mole of copper. Mole of copper. Okay. Now, what you're actually looking for is the value of X. So you divide both sides by the coefficient of X. And what are the coefficient of X? All these numbers are the coefficient of X. So you divide both sides by 6.02 times 10 raised to the power of 23. Divide both sides by 6.02 times 10 raised to the power of 23. This, we cancel this. So we'll be left with X. So X equal to, now if you punch this in your calculator, let's do that. Press this. 4.25 times 10 raised to the power of 21 over 6.02 times 10 raised to the power of 23. Yes. Okay. I'm just trying to confirm it. So this gives us 7 point what? This gives us 7.05. Let's just assume 0.598 times 10 raised to the power of minus 3. Times 10 raised to the power of minus 3 what? Mole. That is another way they can ask you questions. That is another way they can ask you questions to calculate the mole. Another way, which is question number 3 now, in this case. Question number 3 in this case is, now for question number 3, if you have any question, please, you can drop it in the comments. If you have any questions, you can drop it in the comment. Please drop it in the comment. So for question number 3 now, you are given the volume. The volume, that is volume, to be, you are given the volume to be 200 centimeter cube. And you are given a concentration. This is a unit of concentration. They are given a concentration to be equals to 0.025 mole per dm cube. Mole per dm cube. All right, this is very important. Your unit is very important in calculations. Your unit is very, very important. Please take note of that. Now, this is concentration. It is given as mole per dm cube. Dm cube is the unit of volume here. And the unit of volume that was given here is in centimeter cube. For you to know that both of them cannot work together. So we have to convert this centimeter cube to be in dm cube, which is this. You have to convert it from centimeter cube to dm cube. Now, most students, if assuming you are given, you are not the calculator you'll be using the calculator you'll be given in an exam all is quite different from this sciencey calculator. Okay, it's quite different. You cannot be given this kind of calculator, but you need to know how to convert from centimeter cube. You need to know how to convert from centimeter cube to what? To dm cube. Now I will give you an assignment. Let me just say an exercise to do. Although I'm going to show you something here right now, but I will also give you an exercise to do. Whenever you are converting from cm cube to dm cube, you can go home, make little research on how to convert from one to another. For example, from centimeter square to meter square, from centimeter cube to meter cube, from centimeter to meter, like that. This is very important. These are simple things that you come across in an exam. Some students will just apply it straight. You will see the answer, but it may be wrong. So please be very careful of those signs. So converting this one now to dm cube, it will be, so our volume will be 200 over, you divide by 1000. So when you divide by 1000, you have successfully converted it to what? Dm cube, and that will be 0.2 dm cube. Now we have converted this from centimeter cube to dm cube. Now you need to think, okay, now these are the two parameters that were given, and you have to calculate mole. How do you know the right formula to use? You will remember in your practical, probably in secondary schools, that there is a formula that relates concentration, volume, and mole together. Now we are given concentration and volume. So which formula is that relates concentration, volume, and mole together? Now the formula says N equals to CV. You remember this formula in your what? You remember this formula in your practical then in secondary school. That mole is equals to concentration times volume. So our concentration is given to be this. So we have 0.025 times the volume, and the volume is given to be what? We have calculated the volume, converted it from centimeter cube to dm cube. So the volume now is 0.2. So that will be times 0.2. So if you punch that in your calculator, 0.05025 times 0.2, that will give us, so this will give us 5 times 10 raised to the power of minus 3 mole. And 5 times 10 raised to the power of minus 3 is also the same thing as 0.005 mole. 0.05 mole. That is our answer to question number 3. That's our answer to question number 3. Okay, now the next one we look at is question number 4. Please, do you have any questions? Let me know, or let me just ask, do you understand? Do you understand? Okay, there's only one person that responded. Please let me know, do you people understand? Let me know in the comments. Do you understand so far? All right, let's just solve. I don't know whether there's any issue with the live stream, but probably I will check it after this video, okay, so that we'll work on it. If there's any technical error, we'll try to work on it. All right, so let's solve the remaining 2 questions, which is question 4 and 5. This for question 4 and 5. Now for question number 4, you will make use of this formula, and that is this relationship and this relationship. You apply these 2 relationships. That's what you do. You apply these 2 relationships. Now for question number 4 you are asked to calculate the numbers of mole of hydrogen gas. Now this time around we are dealing with hydrogen gas, and now you are given just only a volume of hydrogen at STP. Now look at this volume at STP, relating it with the mole here. So we have 1 mole of any substance But now in this case, I'm not going to write any substance. I will write it as hydrogen because hydrogen is the substance we are dealing with here. So 1 mole of hydrogen, let me write it as this. 1 mole of hydrogen is equals to 22.4 dm cube. 22.4 dm cube. 22.4 dm cube. Okay. Now, if 1 mole of hydrogen give us 22.4 dm cube, what mole of hydrogen that will give us 16 dm cube? If 1 mole of hydrogen give us this, so what mole of hydrogen will give us this 16 dm cube? So it is that mole we are calculating now. Now you can see the importance of this structure. So what we do is to cross multiply. If you are writing this in a theoretical exam, please don't do any cross like this. It simply means you cancel it. But I'm just trying to use this one to demonstrate it for you to understand what I'm actually saying. Okay? So x times 22.4, it will give us 22.4x equals to 1 times 16 will give us what? 16. Then if I make x subject to the formula by dividing by the coefficient of x, I will divide by 22.4 divided by 22.4. So this will cancel this. X now equals to, now 16 divided by 22.4. 16 divided by 22.4. So this gives us 0.714 mole. 0.714 mole. So that is for question number 4. Question number 4. Now for question number 5. Please listen to this question number 5. Listen to this question number 5. So far so good. You can see that all what you have been asked to calculate since the beginning of this class is mole, but using different approach. That is what is affecting students. You may only know this part or this part and come across another way of calculating moles in an exam. That is why you need a better understanding of how to do things rather than solving past questions. In case they change the questions, you may see this one last year or this two last year, and this year you may come across this. So it's good that you understand. It's good that you understand how to calculate it rather than you memorizing or mastering how to cram those what's it called? Those rather than you mastering how to calculate how to cram those past questions. So now for question number 5, write out our givens. We're given that the volume, so we say solution, that is number 5. Write out the parameters that we're given. We're given the volume. Volume is equal to 250 centimeter cube. Mind you that we still need to convert this 16 centimeter cube. Okay, you are given pressure. This is the pressure given. So you are given pressure equals to 720 mmHg. You are given temperature T equals to 37 degrees Celsius. Okay. All right. Okay, that is the parameters given. Now, you have to calculate the number of mole. What you need to do here is think which formula that relates pressure, volume, and temperature. In fact, anytime you are solving question and you come across something like ideal gas, first question that should come to your mind, first formula that should come to your mind is PV. This is the first formula that should come to your mind. PV equals to nRT. Whenever you are solving a question on either gas law or in stoichiometry and you come across ideal gas, this is very important. This should be the first formula that should come to your mind. Now, from this formula now, we're given pressure to be this. Our pressure have been given. Our volume have been given. This is what we have to calculate, which is the mole. Now, the rate is constant. It's a gas constant. And the temperature is given. You can see that all of them we can be able to determine the parameters of all of them except only this mole, which is what we are asked to do what? To calculate. Now, this pressure, we need to convert it to atm, because the rate, the what's it called? The rate, this R is a constant, and our R is equals to 0.0821. Take note of the symbol, please. ATM dm cube. Let me try to get it. dm cube mole per mole per Kelvin. Per mole per Kelvin. Now, this is the unit. This is value of R. It's a gas constant. It is constant, and you can see the unit, that atm dm cube mole and Kelvin. What this tells us is that your temperature, your pressure, atm is a unit of pressure. Your pressure must be in atm, your volume must be in dm cube. Take note of that. And your temperature must be in Kelvin, which means we need to convert this one to dm cube, this one to atm, and this one we need to convert it to Kelvin before we can solve anything. So let's do that here. Now let's start one after the other. Converting the volume now to Kelvin. Converting the volume, we have V equals to 250 over 1000. That is how you can convert from centimeter cube to dm cube. And when you do that, it will give you 0.25 dm cube. Okay. Now, another one we need to convert is our pressure. It must be in atm. It must be in atm, not mmHg. So our pressure is equal to, converting from mmHg to atm, you divide by 760. So that will give us 720 divided by 760, and that will give us, let's do that, 720 divided by 760. So press this. This gives us 0.9474. Okay, that is for that. Now we have done with volume, we have done with pressure. The last one to convert is our temperature. The temperature is in degrees Celsius, so we need to convert it to Kelvin. So temperature, let me just say temperature equals to 37, that is 37 plus 273. 37 plus 273. 37 plus 273, that is 310. So this gives us 310 Kelvin. 310 Kelvin. All right. Now, since we have successfully converted our parameters, we can substitute them into this formula, to get our numbers of mole. So making numbers of mole here is subject to the formula. I will divide both sides by the coefficient, which is RT. So that is, we have N equals to, if I divide what is here by RT, if I divide it by RT, divided by RT, so I will have this, we cancel this, I will left with N equals to PV over RT. PV over RT, that will be PV over RT. Our P is equals to pressure, that is N equals to, P is equals to pressure, and our pressure is given to be 0.9474. Okay, now times V. What is our V? Our V is volume. The volume is now this, no longer this. It's no longer this. We have converted it to dm cube. So the volume is times 0.25 over, what's our R? This is a gas constant. It represents the gas constant, which is 0.0821 times our T, temperature. We have converted it to Kelvin, which is 310. Okay, so let's punch that in our calculator. So let's do that. 0.9474, 0.9474 times 0.25, 0.25 divided by 0.0821, 0.0821 times 310. Okay, I hope we can all see that. So this will give us, yes, so numbers of mole here is equals to 9.3061, 3061 mole. 3061 mole. I'm coming. Sorry, it's times 10 is power of, sorry, times 10 is to power of, you can see it is times 10 is power of 3 minus 3, sorry, times 10 is to power of minus 3 mole. Yes, times 10 is to power of minus 3 mole. And another way you can write it, you can also say n equals to, if you want to convert it to decimal, you can say it's equals to 0.0093, you can leave it as 0 or leave it like that, mole. So that is our final answer to that. As our final answer to that. Someone said I. Okay. All right. Thank you very much for watching. We try to check if there's any technical error, so we try to improve, work towards that. Okay. And I sincerely appreciate I sincerely appreciate every one of you that stayed to the very end. Thank you so much. If you have any questions, please, or you notice anything that you like to correct, or maybe due to an error, maybe technical error or anything so far, please do it to drop it in the comments. Okay. Thank you so much. Please, will be going live often and often now. Like, we'll be going live consistently now. Okay, please stay tuned for more. Thank you.